in the last class. So talking about chemical combination, we're talking about how chemicals combine together. How chemicals combine together, in the sense that for a chemical reaction to occur, for a chemical equation to occur, chemicals will have to combine together. Now we're starting with chemical equation. Chemical equation is just the written statement of a chemical reaction. It's more like just saying observing chemical reaction with bio and paper. You can just say it that way. That observing chemical reaction with bio and paper is what chemical equation is referred to. For example, let's say the reaction of hydrogen and oxygen to form water. We know the combination of hydrogen and oxygen that give us water. Now, in order for us to represent it, we have to write it down with the bio and paper. This is called chemical equation. So in a more formal way, chemical equation is the condensed statement of facts about chemical reactions. Now, for every chemical reaction, the reactant side, we have, at the left-hand side, we have the reactants, while at the right-hand side, we have the products. Like the one we're having on the slide there, we have hydrogen, 2 molecules of hydrogen reacting with 1 molecule of oxygen gas, giving us 2 molecules of water. So we can also do for water and sodium chloride, which is our salt. You know, you putting salt inside water is something you can represent chemically with your biro and paper. So being able to represent that with biro and paper is referred to as what? Chemical equation. So if we add water and salt together, we'll be having sodium chloride plus H2O, giving us sodium hydroxide and HCl. So that aside. So now there are some laws of chemical equation that make us to understand chemical reactions. Or let me say laws that allows chemical reactions that bind chemical reactions together. You know, for chemical reactions to occur, there are some laws in chemistry that allows or make those reactions to occur. Let me put it this way. These laws are called the laws of chemical reactions. They are called the laws of chemical reactions. So these laws enable equations to occur. Let's say, for example, law of conservation of mass. We state that all matter can either be created or destroyed during chemical reaction, but change from one form to another. This implies that no matter a change that matter will undergo, the matter can't be destroyed. So if a matter is undergoing a reaction, there will definitely be a product. That's the meaning of that statement. Hello?
Your voice is a little bit low.
Low?
Can you hear me?
Okay, okay.
So yeah, can you hear him clearly and loud and clear?
Yes.
Loud and clear, right?
Yes.
Oh, okay.
You can hear me loud and clear.
Maybe it's from my hand.
Okay, okay. So as I was saying about law of conservation of mass. Now this law states that matter can neither be created nor destroyed, which implies that if a matter undergo a chemical reaction, there will definitely be a product because it can't be destroyed. There will be a product for that reaction. Let's say, for example, the burning of methane. When a methane burns, it is not destroyed. It is not destroyed. But if it is destroyed, there will be no product for that equation. And because it is not destroyed, that's why the product for the equation for the reaction is CO2 and H2O. So this is what this law is making us to understand, the law of conservation of mass, that matter can neither be created nor destroyed during chemical reaction, but there will be a change from one form to another. That is, there will be a change from one form to another. As I use the example of methane. When a methane bonds, that is CH4 plus oxygen. When a methane bonds, we have CO2 plus H2 as our product. The reason why we have CO2 and H2 as our product is because methane was not destroyed. There was only a change in the form of methane, giving CO2. So that is what this law is making us to understand. So irrespective of the action that the matter will undergo, there will always be a change. There will be a change. Nothing will be created nor destroyed. Law of definite proportion says that all pure samples of a particular chemical compound contains the same element combined in the same proportion by mass. Now, this law is talking about the purity of matters. That's the law of definite proportion. It's talking about the purity of matters. That matters that are pure, matters that are pure will retain their constituent the way it is, so far the matter is pure. Let's say, for example, water, for example. We know that water is made up of H2O, that is, two molecules of hydrogen and one molecule of oxygen, H2O. We know that that's what water is made up of. Now, irrespective of where the water is coming from, so far the water is pure, it will retain this constituent. This is what this law is telling us. So far the water is pure, it will retain this constituent. Let's say spring water, for example, spring water, well water, river water. So all this water I just mentioned now, so far these waters are pure, they will retain the constituent they are expected to have. That is, two molecules of hydrogen and one molecule of oxygen. But in a situation whereby the water is not pure, the constituent of water will be affected. So there's a possibility that if the water is not pure, its constituent will not remain as two molecules of hydrogen and one molecule of oxygen. Let's say seawater, for example. So this is what law of definite proportion is telling us, that all pure samples, no matter what the sample, no matter where the sample is coming from, it will always retain the same amount of element in the same proportion it is. Now, the next law is law of multiple proportions. Now, law of multiple proportion explains how multiple elements can combine with each other in multiple ratios. That is, we can have a reaction of multiple elements combining together in order for a reaction to occur. Like for example, a compound A, compound B, they can combine together to have compound C and compound D. Let's use the reaction of salt and water, for example. Or let me say the reaction of ethanoic and ethanol. And when ethanoic and ethanol react together, we have ethyl ethanoate plus H2O. So multiple, this was telling us that multiple compounds can combine together and give us a product. I believe that's understood. Any question? Any question on this? Is there any question pertaining to these three laws of chemical reactions? Do you understand? Balancing chemical equation. Balancing chemical equations. So balancing chemical equations. Balancing chemical equations. Now, when talking about balancing chemical equations, there are some steps we have to take in place in order for us to be able to balance a chemical equation very well. Now, for example, now, like the one on our slide here, we have that of combustion of ammonia. Now, the step one is you have to know all the reactants and products involved. So for every reaction, before you can be able to balance it, you should know the reactants and the products. For example, the reactants for this is ammonia and oxygen gas reacting to give nitrogen oxide and water. Now, that's the first step. So you place the reactant at the left-hand side and the product at the right-hand side. Then step two, you check the number of each type of atom on the left and right sides of the arrow. Now, for us to balance this, let's place 4 on let's place 4 beside NH3. So we have 4NO plus 6H2O because we're already having 4 nitrogen. So because we're already having 4 nitrogen, yeah. So since we have 4 nitrogen and the reactants, we also have 4 nitrogen on the product side. Now, our number of hydrogen here is 12. 4 plus 3, 4 times 3, that is 12. So therefore, we also have 12 H2O here, or 12 hydrogen here also. So since we already have 2 hydrogen, so we'll place 6 there, making it 12. Now, step 3, you write coefficient to balance the formula equation. Now, to balance this, since we already have 4 nitrogen here, so we can place 4 beside nitrogen oxide. So with that, the total number of oxygen we're having here now is 10. So making us to have 5, having 5 as the coefficient for oxygen gas. So this is just how reactions must be balanced. So the main fact about balancing the equation is that let us make sure that the atoms in the reactant side are equal to the atoms in the product side. So if that can be established, your reaction is balanced. So we'll be coming to an end of today's class. We'll be coming. Hello. 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 We'll be coming to an end of today's class. And the participant hear me?
Yes, we can hear you. Suliat, why are you not saying anything?
Sorry, sir, I can hear you.
Yeah, you should have
responded. Can you hear me?
Can you hear?
Yes.
I believe you understand. Do you understand what we've been able to discuss?
Yes.
Okay. So that is that about balancing equation and the law of chemical equation. I believe you are able to see the slide.
Yes.
Okay, good. And I want you to try the assignments there. Try to balance the equations there towards next class. Okay. So you can just try to balance this equation here now, like nitrogen and hydrogen, NH3. Okay, ma. Hello?
Sir?
Can you try to balance this equation here?
Yes.
Yeah, now, but to balance this, N2 plus H2, we have NH3. So what to be the coefficient to balance this one?
The N will be 2. The hydrogen will be 6, and the NH3 will be 4.
Okay, so the N will be what? 2.
The nitrogen will be 2.
Good.
The hydrogen will be 6.
6, okay.
ammonia will be 4.
Correct. So it's just make sure that the product side is equal to the reactant side. So that's very, very good. So we'll continue from there in our next class.
Okay, sir.
By next class, we'll be having a better class. Okay. Okay, sir.
All right, sir.
Okay, sir. Bye-bye.
Bye-bye, sir.
Okay.